zaczął być w drugą stronę, czyli zaczęła się ekspansja, czyli zaczęło się wszystko rozszerzać, tak jak mówią o tym balonie, że to się wszystko rozszerza, oddala się od siebie. Tylko teraz tutaj rodzi się pytanie, które pewnie wielu przyszło do głowy, może nie, może tak, ale w czym się to rozszerza, ten balon?
And the only thing I got with me is this book. It's called Gravitation. It's like the Bible of relativistic physics. And it's called gravitation because when you pick it up, you know, you can really tell gravity is acting upon things. And I was, you know, going through the equations with them, and I'm talking about all this, and I'm really, you know, going through it with them, and I can see that there's a certain amount of irritation, and there's a certain amount of impatience with me because I'm asking very simple, fundamental questions. And everybody there is doing very advanced, you know, string theory physics and all this. And, you know, I'm always going back to like some fundamental things. And they're like, my God, what is this guy doing here, kind of deal. And, you know, and so at one point, I pulled out my book, Gravitation, and I said, okay, after all these equations, which is a few thousand equations, on the metrical structure of space and then applied to the universal size and so on, the model of our universe at this point, and correct me if I'm wrong, is that the universe is expanding like a balloon. And I opened the book on page 219 and I pulled it out and I said, here's the picture of what we believe the universe is doing right now. It's expanding like a balloon, and the balloon has little pennies glued to it, and the pennies represents galaxies. That's the standard model. And the galaxies are moving away from each other as the balloon expands. And everybody's like, yes, and that's, where are you going with this kind of deal? Like, if you don't know this, go back and study, come back in a few years. And at one point, well, I'm saying, well, okay, I understand this principle. However, I have a question. Out of all these equations everywhere, what I want to know is where is the equation that represents who's this guy? And the whole room became really silent. And I could see that in the look of the students and the other physicists that there was a look of despair and stress because sweat was a little bit beading. And I could tell that they got worried because they thought, oh my God, this guy, he might just start talking about God, and we're at Georgia Tech in the physics department. We can't do that. and I reassured them very quickly. I started to draw, and I said, well, you know, let's draw the rest of the guy. And what I'm trying to point out here is that in order for the balloon to expand, then the lungs of the person that's blowing into it have to contract. For every action, there's an equal and opposite reaction. Okay? One of the first laws of physics. So if our universe is expanding, then there must be something contracting. There must be some compression happening in order to get expansion. There must be a feedback between the expansion and the contraction. And that was my first clue to the relationship between the gravitational field and the electromagnetic radiation.